So today you learned about equations like y equals 3x plus 1 and y equals x squared, and how they do not have a constant proportionality. So they do not represent proportional relationships. So let me give you an example. Look at these two graphs. And let's say this is the number of tickets. So this is the x-axis, this is the y-axis, and this is the number of tickets that you buy. And this is the cost. I go to a street fair or a carnival. Here's 0, 1, 2, 3, 4, and so on. So let's say that one ticket is $5. One ticket's $5. Two tickets would be $10. Three tickets would be $15, and so on and so on. And let me just do one more because that's what I wrote. It'd be $20. This is a proportional relationship. Well, if you think about it, if I asked you to find the constant proportionality, you would say, oh, here's the unit rate, right? And this is the constant proportionality because I'm multiplying everything times 5, times 5, times 5, times 5, times 5. So if I were to graph this, all right, 5, 10, 15, 20, right? So one ticket, oh, actually, let me take that back. What if I buy 0 tickets? Well, if I buy 0 tickets, it'd be, $0. So there's a 0 here. 0 tickets, I pay $0. So one ticket is 5, 2 tickets it's 10, 3 tickets is 15, 4 tickets is 20, and so forth and so forth. So if I were to connect this, right, that's what would a proportional equation look like. Now, what if it's not what's not proportional? So let's say we went to the different fair. Again, y represents the cost, and the x-axis represents the tickets. But this fair has a little something different. 1, 2, 3, 4. They have a parking fee. So you park the car and your parents pay $2. The tickets are still $5. Right? So let's do the table. So if I buy 0 tickets, guess what? I still pay $2. Because I parked the car. Let's say I parked the car, and then my nephew, who was willing to go, all of a sudden gets sick, and I have to go home. Well, I still parked for the car, and I still pay $2. What if it was one ticket, just me? I have to pay the parking fee, which is $2, plus the ticket to get in, and I'm actually paying $7. So one ticket. So for one person, all right. Actually, let me change this instead. For one person, I would pay $7. What about 2 people? 2 people, well, 2 times 5 is 10, but I gotta add the parking fee, and I end up paying $12. 3 people, well, it's $2 for the parking, and 3 times 5 is 15, I paid 17. Let's graph that. So if I get there, all right, 0, and I park the car, and I don't know, I had an emergency, and I have to go back home, guess what? I turn the car around, but I still pay for the parking fee. So notice that it doesn't start at the origin. So at 0 people going in, 0 tickets purchases, 0 people going in, I'm sorry, I still end up paying $2. And that's where my graph starts. It doesn't start at 0, 0. Well, one person, look, it's $7. 2 people, 12. So, and then we can go on and on, but there's a difference between a proportional, this is a proportional relationship, and not proportional. And on a graph, how does it show? Well, one starts at the origin, the other one doesn't start at the origin. Why doesn't this start at the origin? Because in this scenario, there was a parking fee of $2, even though I didn't buy any tickets. Okay, so just a different view of looking at it. Let's go with the problems. Complete the table. Let me clear this, clear page. Says the relationship is the distance in yards, y, right? And miles, this is my x column. And the equation is y equals. So to find y, to find these numbers here, I have to multiply. And where's my constant proportionality? Right here. So I'm going to write right off the bat that that's my K. So I can go over here and times it by 1760, 1760, 1760 times 1760. So 1 times 1760, 760, 5 times, I have no idea. Let's see if I can get it. Yeah, I have a calculator. 5 times 1760 is 8,800. Now what about these two? Well, these two, I'm going this way. Right, I'm going that way. So I gotta find something multiplied by 1760 is 3,250. Now you could divide 3,250, sorry, 3,550 divided by 1,760 is 2. And this one is always obviously 10. And that's how I got the numbers. Complete the table. Is there a proportional relationship between the distance in yards and the same distance in miles? Yes, there is. Why? Because the constant proportionality, as you can tell, is the same. 1, right? So 1 times 1,760 is 7,060, and everything else follows through. It's the same constant proportionality over and over. So that makes my table proportional. All right, so the remaining length of a 120-inch rope after X inches being cut off is 120 minus X. So, give me 1 second. Sorry, guys, just give me 1 second. Almost there. While I'm need a couple of minutes, I want you to remember that any proportional relationship, the equation comes in this format. Y equals kx, right? That's it. That's the equation of a proportional relationship. Okay. Now, if you look at the first one, right, it says L equals, so it says actually 120 minus X equals L. So let's just change it around. So let me make L equals 120 minus X. Is this equation in this format where we have a constant proportionality multiplied by the X value? Well, you can say that it's not the same, right? Because this is subtracting, and what's happening between K and X, it's a multiplication, right? So this is not proportional. The second one, sorry, taking a while here. 1 segundo, por favor. 1 segundo, por favor. All right. Second one. Look at the equation. Let's look at the equation. Let me bring it to the side. 1.08p equals t. Is this in this format? Well, let's change it around, right? So let's switch sides. So we get t equals 1.08 times p. Look at the equation and look at if it's in this format. It is, right? So this is our constant proportionality, which is k, and it's multiplied by a variable, okay? Or in this case, the value of the item p. So to find tax rate, if you want to find the price of the item with tax, to find the total, you would multiply 1.08 times p. So this is a proportional relationship. Next one's tricky. Next one says, remember, it should be in this format, right? But the format says x equals m over 4. And you're going to say, well, that doesn't really look the same. So the trick here, instead of writing m over 4, so m divided by 4, it's the same thing as writing 1 over 4 times m. Now is this in this format? Do we have a constant proportionality k? Yes, right there. Okay, and is it been multiplied by another variable? Yes, it is. So this is also proportional. Last one, v equals 12. Here's my constant proportionality times the variable s, but s is to the second power. Remember, a proportional equation looks like this. So we do have a constant proportionality, which is k, but notice that here, this is x to the what power? To the first power, and this is s to the second power. So are they the same? Are they in the same format? No, they're not. So it makes this not proportional. Determining whether each or not the relationship is proportional. Okay. So let's find the constant proportionality. So to find the constant proportionality, I'm going to take the y value and divide by the x value. So if I pick this guy right here, I go 5 over 2. And k, and I'm just going to write 5. Well, actually, I can write 2 over 5 or 5 over 2. It's up to you. So I'm going back to my table, and I'm going to write times 2.5 times 2.5 times 2.5. 3 times 2.5 is 5, that's right. 3 times 2.5 is 7.5, that's right. Is 6 times 2.5 15? Yes. So this table represents a proportional relationship? Yes, because every pair has the same constant of proportionality. Now, this one over here, again, look at your equation that represents a proportional relationship is in this format. So this is almost, here's my y, here's my 3.2, which is the constant proportionality times x, but it has something extra, the plus 5. Is it, so are they both in the same format? They're not. So this one, no, it's not proportional. Okay, because we're adding 5. Okay. And it's, like you can tell, not in this format. Okay, so, but if it was just like this, y equals 3.2x, then that would be a proportional relationship. Okay, see, not that crazy. 9, 10, the weight of a stack standard 8.5 by 11-inch paper and the number of sheets of paper. Well, let's see, the weight. So if you look at a ream of paper, right? Here is the ream of paper, and there's sheets in here, 500 sheets. So is the weight, and the number of sheets have a proportional relationship. So, for example, if I have one sheet of paper, right, you can always create a table. And it weighs, I don't know, I have no idea how much. Alexa, how much does one sheet of paper weigh?
From reference.com, a standard sheet of paper measuring 8.5 by 11 inches weighs 0.16 ounces.
0.16 ounces. What if I have two sheets of paper? Well, it'd be times 0.16 or 0.32. What if I had three sheets of paper? It'd be 0.48 and so forth. Now, I created a table. So now, times 0.16, times 0.16, times 0.16. So what if I had 100 sheets of paper? What would you do to find the weight? Well, times 0.16, and that would give you 16 ounces, right? Etc., etc. So, is the constant proportionality the same when you relate to the number of sheets and the weight? Yes. So, is this proportional? Yes, it is proportional. Okay, so you can always create a table to make life easier. All right, so let's see. The weight of a stack of different size books. So you have a book here, right? And then you have another book, and I'm going to make it smaller, right? And then you have a big book, right? So let's say I put one book on top of each other. Are the weights proportional? So if I had one book, let's say one large book, let's call it 1.5 pounds. Very large book. What if I had 2 books? One large, right, and one medium. Well, this is 1.5 pounds. This is 1 pound. Well, so if I had these 2 books together, it would be 2.5 pounds. What if I had 3 books? Let's make this 0.5 pounds. I had the small, the medium, and the large. So if I add this, I would get 1.5, 2, it would be 3 pounds. Right? So just like I created, right, this relationship. So let's look at the constant proportionality. How does a 1 become 1.5 times 1.5? So it'd be times 1.5 times 1.5. Now, 1 times 1.5 is 1.5, so that's okay. But 2 times 1.5 is not 2.5, it fails. 3 times 1.5 is not 3, it's 4.5, so it fails. So again, remember, different size books. If they were all the same, that'd be a different story. Same book, that'd be a story. But because they're all different, no, it is not proportional. So, visuals, table, all came along in this particular problem to help out. Okay. Liam and Sam are running 60-meter race. Okay. Where each distance, time, is information. Liam distance is represented with the equation y equals 6x. So, who's who? Y is the distance. Let me write here. Y represents the distance, and x represents the time. But it says here, let me write x and y. So let's just do Liam for now. So this says for Liam that in order to find y, what do I have to multiply everything by? It says multiply by 6. Where do I get that? Right here. That's my constant proportionality. So it's times 6, times 6, times 6, times 6. So obviously if he doesn't run, his distance is 0. If he ran for 2 seconds, 12, 24, 36, 48. Right? So for Liam, assuming that his speed is constant, right, that would be the table. For Sam, okay, so actually for Sam, I'm going to write time here and I create a table here. 0, 2, 4, 6, 8. So for Sam, let me change colors. For Sam, it says 8 seconds, and here's 8 seconds. Here's the time. 8 seconds. It says that in 8 seconds, this fellow here he ran 18 meters. Is that what it says? 8 seconds, 16 meters. Okay. So 4 seconds would be, so again, what's the relationship here? How this, it's times 2, times 2, times 2, times 2, times 2. If Sam runs for 2 seconds, doesn't run, it runs for 0 seconds, it'd be 0. If he runs for 2 seconds, it'd be 4, this would be 8, this would be 12. What is the question asking? Sorry. At 8 seconds, yeah, he ran 60 meters. So, is that it? Sam says that in 8 seconds he ran 16 meters. So it is well, I guess that's it. Spiral. Y equals 3.5. So let's create, again, let's create a table. Here's my Y, here's my X. Here's my constant proportionality K. So I know each of these rows, we're going to multiply by 3.5. Right? So whatever X value, to get the Y value, you're going to multiply by 3.5. Oops. sorry, this was. I have a table. Now I need some y values. What does this 3.5 represent in the equation? Well, let's get to that in a second. Y, this is the cost in dollars. And what does X represent? The ounces. So we're looking at blueberries. So if I buy 1 ounce of blueberry, how much will it cost? It will cost me $3.50. What if I bought 2 ounces of blueberries? Well, it's going to cost me $7. 3 ounces, $10.50. 4 ounces, $14. So now we can answer some of the questions. What's the unit rate? Here's my unit rate. For every 1 ounce, for every 1 ounce, I pay $3.50. Right. So what's the 350 represent? What does 350 represent? It represents the cost. It represents the cost per ounce. So it's 350 per ounce. The number of blueberries that $1 can buy. Oh my God. The number of blueberries. What? Oh, those are the others. So the question is, what does the number 3.5 represent? Situation. It represents the cost for 1 ounce of blueberries. Right here. Right, and I got that from here. So it's always nice to create a table. You can find the unit rate, make it a sentence, and then look. For every 1 ounce, I pay $3.50. So what does the $3.50 represent? $3.50. It's the price of $1 of 1 ounce of blueberries. Reflection? No, thank you. Is the relationship between the weight of cherries and the cost of cherries proportional or non-proportional? Well, let's look at it. So let's find a constant proportionality. Find a constant proportionality. Remember, it's y over x. In this case, this is y and this is x. Actually, well, we'll talk about that later. So let's divide 9.98 divided by 2. And we get 4.99. So if I had times 4.99 times 4.99, etc., etc. So let me add a column here. What if I had just 1 pound of cherry? It would be 4.99, right? So is it proportional? Well, I just multiply. Yes, this is right, that's right, and that's right. So for every 1 pound, here's my unit rate. For every 1 pound, I pay $4.99. Okay, the constant proportionality is $4.99. And what's that represent? It represents the cost per pound. Okay. Blah blah blah. And determine if each table shows a proportional relation, not proportional. If the relation is proportional, determine the constant proportionality. Okay, that is easy. Right. So let's take a pair. Find the constant proportionality. So I'm going to divide k. I'm going to divide. Let's make this y and this is x. So 25 divided by 1, and guess what? It's times 25. And I already knew that because in the unit rate, which is here, this tells me what the constant proportionality is. And let's see if the table is proportional. It works here, it fails here, fails here, fails here, fails here. So this is not proportional. Right? Because there's no way 2 times 25 is 49. This one, where's the constant proportionality? It's right here because that's my unit rate, so it's times 23, times 23. I didn't have to divide. 2 times 3, 46. Good. 3 times, yes. 12, carry 1. Yes. 15, carry 1. Yes. Yes, 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 yes. Proportional. Well, here's my unit rate, so it's times 20. Everything should be times, should be. And you can see that it already fails. That's a no, that's a no, that's a no, and this is a no. Not proportional because it should have every relationship, between days and pages read should have the same constant proportionality, so obviously this is not. table shows the cost of renting a catering hall, based on the number of guests. So if you have 75 people, they're going to charge you $8,250, 100 people, $11,000, 150 people, $6,000, $16,500. Is it proportional or not? Well, what if I have one person coming to my party? How much will I pay? Well, let's find the cost proportionality. Divide, obviously, right? We're going to divide this column by this column, right? So in order to find this number over here, we divide 8,250 divided by 75. And what's the cost per person? And it's 110. Well, times 110, times 110, times 110. If I had one single person coming to my party, it'd be 110. So there's my constant proportionality. What's my unit rate? Well, for every guest, for every one guest, I should say, I pay $110. So if they asked you what's the $110 represent, it means the cost per guest. $110 represents the cost you're going to pay per person showing at your party. Multiply everything. Let's try 150 times 110. Does that work? It works here, it works here, it works here, and obviously it works here. So is this proportional? Yeah. You can add all this stuff that I'm doing here, right? Predict the cost of renting the catering hall if 200 guests come. Well, that's easy. If 200 people come, I know how much is it per person. It's $110. So 200 times 110 equals $22,000. That's it. Four, the table represents something. Let me actually just find this. They're asking us if the relationship is proportional. The table represents a number. Okay, first of all, let's check it out. Number of tickets. So let's find the unit rate, right? Times what? Times what? Times what? And let's put in one over here. Time and 1 times. So we gotta find the unit rate. To find the unit rate, divide 2 by 5, the $2 by the number of tickets, and we get that the unit rate, okay, is 40 cents. 0.4. So 5 times 40 cents is $2. 20 times 40 cents is 8. 100 times 40 cents is 100. And then 1 ticket times 40 cents is 0.4. So what does 0.4 represents? The cost per ticket. The table represents a non-proportional relation. That's false. The table has equivalent ratio. That's true. The price per ticket is the same regardless of the number of tickets purchased. That's true. So if you bought 200 tickets, would it still be 40 cents per person or per ticket? Yes, so that's true. The constant proportionality to determine the price of the ticket is 250. Not, that's false. The constant proportionality to determine the price is 40 cents. Yes. There is no constant proportionality. So actually, this is true. And last one, I don't even know why they put it there, because that's false. Five. Sean determines the pattern in the table shown and concludes there's a proportional relationship between the quantities. Do you agree with Sean? Explain your thinking. All right. So if you don't like it that way, you can write it this way. So 1, 2, 2, 4, 3, 8, 4, 16. If you want to look at the table this way, you may. All right. So is this table a proportional relationship? Well, let's find the constant proportionality. Well, so constant proportionality is actually here. Right. This is my unit rate. Once you have the unit rate, let's call this x, let's call this y, we know that this 2 over here is a constant proportionality. So it should be times 2, times 2, times 2, times 2. So this is okay, this is okay, this is not okay, that's not okay because it fails. 3 times 2 is not 8, 4 times 2 is not 16. So is there a proportional relationship between? The answer is no. Okay. 6, 3 pieces of fruit A, hang on a second, for and 3 pieces of fruit B, okay. The total weight and the price, blah blah, and okay. Wait a second. Okay, is there a relationship between the price of the fruit and the number of fruits purchased? So, is there a relationship is the relationship between the price of the fruit A and the number of fruits purchased proportional. If I buy one fruit, so we're going to ignore this for question A. We're looking at this. It says, is there a proportional relationship between the number of fruits and the total weight? So let's say I bought one potato. It weighs 4.2 ounces. If I buy, so notice that it's 4.2, right? Makes sense? So this is a constant proportionality. So if I buy 2 of the fruits, it should be times 4.2. If I buy 3 times 4.2. Now, we all know that fruits come in different weights, right? Different shapes. Well, not different shapes, but, well, very similar, but they're not exactly the same, and they don't weigh exactly the same weight. No two apples look exactly 100% the same. So, is a relationship between the number of fruits and the total weight. So if you bought 4, let's call these apples. If you bought 1 apple, it weighs 4.2, so 2 apples should be 8.4. Is it? No, it's not, because the second apple, looks like it's a little bit heavier, right? It's supposed to be 8.4, but it's 8.7. So is there a proportional relationship? The answer is no, because the same fruit, they are not exactly the same, and therefore they don't weigh exactly the same price. That's what question A is. Question B. Which fruit's price is determined by the number of fruits purchased? Okay. Well, let's look at this one. Let me erase this one here. We're talking about the number of fruits and the price. So if I buy one fruit, I buy 50 cents. What's my constant proportionality? Times 50 cents. If I buy 2 fruits, well, it should be times 50 cents. And 2 times 50 cents is $1. Look, that works. If I buy 3 fruits, times 50 cents, $1.50. So for this fruit, I don't know, let's call it oranges. 1 orange is 50 cents. If I buy 2 oranges, it's 2 times 50, which is $1. If I buy 3 oranges, 3 times 50 is $1.50. So is there a proportional relationship here? Yes. Yes, there is. And it's the constant proportionality is this guy here. Right? If you bought 4 oranges, it'd be times 0.50, which gives you $2, and so forth and so forth. So for the last one, the answer is yes, and you can write all that stuff. All right, that's it.